Have you ever been staring at a math problem and you see an exponent that's a fraction? It can look super intimidating, right? Like some secret code that only a math genius could possibly understand. But I promise you, it's not. It's really just a compact set of instructions, kind of like a recipe. And today, we are going to crack that code together. So let's just dive right in. Take a look at this. 8 to the power of 2/3. I mean, what is that even asking you to do? It looks weird, I get it. But this is the exact puzzle we're going to solve. By the end of this, you'll know exactly how to read this. No problem. Okay, so this is it. This is the big aha moment, the key that unlocks this whole thing. A fractional exponent is just a fancy shorthand way of writing a root. And the most important piece of that fraction is the number on the bottom, the denominator. That number tells you exactly what kind of root to take. So if you see a 2 on the bottom, that's a square root. If you see a 3, it's a cube root. Simple as that. And hey, you don't just have to take my word for it. This rule flows perfectly from the exponent rules you probably already know. Just follow the logic for a sec. We all know that the square root of 5 times the square root of 5 is just 5. So if we pretend for a second that the square root of 5 is 5 to some mystery power, then that mystery power plus itself has to equal 1. Well, what number plus itself equals 1? 1/2. It's not magic, it's just solid math. Okay, so we've cracked the denominator. That's the root. But what about the number on top, the numerator? Well, that's the second part of our recipe. The denominator, n, tells you the root to take. The numerator, m, tells you the power to apply. See? It's just a two-step instruction, all packed into one neat little fraction. Now, the cool thing is, you actually have a choice in how you follow this recipe. You can either take the root first and then apply the power, or you can apply the power first and then take the root. Look at 27 to the 2/3. Either way you do it, you get the same answer, 9. But one of these paths is so much easier than the other. And just because you can do it both ways doesn't mean you should. Seriously, here's a pro tip that will save you so many headaches. Always do the root first. Think back to that last problem. Would you rather calculate the cube root of 27, which is just 3, or the cube root of 729? By taking the root first, you make the numbers smaller and way more manageable right away. It's just working smarter, not harder. All right, let's talk about a super common trap. When people see 1/2 as an exponent, their brain just wants to cut the number in half. But nope, that's not it at all. 100 to the 1/2 power is not 50. You have to remember the rule. The denominator is the root, so it's asking for the square root of 100, which of course is 10. Don't fall for that trap. All right, you think you've got it down? Ready for a little plot twist? What happens if the exponent is negative? It might look even scarier, but here's the secret. A negative exponent has only one job, and it's a simple one. It just means flip the base. That's it. It doesn't make the number negative. It just takes the reciprocal. Let's walk through a full example. 8 to the negative 2/3. Okay, step 1, that negative sign. It just tells us to flip the base. So bam, we get 1/8 to the positive 2/3. Step 2, the denominator tells us to take the cubed root. The cubed root of 8 is 2. And step 3, the numerator tells us to apply the power. We square that 2 and we get 4. So our final answer is 1/4. See? You just follow the recipe one step at a time. This is so important to get straight in your head. A negative sign in the exponent means flip it. A fraction in the exponent means root it. They are two completely different instructions that do two completely different jobs. You have to make sure you don't get them mixed up. And you know what the best part of all this is? You don't have to learn a whole new set of complicated rules. All those properties of exponents you already learned, multiplying means you add the exponents, dividing means you subtract, and so on, they all still work perfectly with fractions. This is awesome because it makes simplifying really complex-looking stuff surprisingly easy. Okay, let's put everything we've learned together and tackle something that looks, well, pretty gnarly. This is where you'll see how powerful these rules really are. We're going to simplify this big, messy expression using every tool we've just talked about. All right, let's break this monster down. First things first, let's group our like terms. Get the x's with the x's and the y's with the y's. Now, since we're dividing, we just use the quotient rule, which means we subtract the exponents. But be careful with those negatives. For the x's, 2 minus negative 1/2 gives us 5/2. For the y's, negative 2/3 minus negative 3 gives us positive 7/3. And just like that, the whole thing is simplified. And that's really it. That's the secret. A rational exponent isn't some crazy, scary, new kind of math. It's just a super efficient way to write down a list of instructions. Once you know how to read the code, denominator is the root, numerator is the power, negative means flip, it all just falls into place.
So why do we even care about this? Because it's a really powerful tool. It takes two ideas that used to seem totally separate, roots and exponents, and brings them together under one unified set of rules. This lets you simplify problems that would be a nightmare to deal with otherwise, and it becomes an absolutely essential building block for calculus, physics, engineering, you name it.
So, we've cracked the code for integers and for fractions. But it kind of opens up a whole new set of questions, doesn't it? If exponents can be these types of numbers, what's stopping them from being others? What could it possibly mean to raise something to the power of pi? Or, get this, what about raising something to the power of an imaginary number, like I? Now that is a puzzle for another time.